So yesterday in class, we did our lab, and some things that you need to think about and you need to know about is that when we do labs, you're gonna have to log in and do the Google Meets with us. Now, this was our first one to do. Y'all's lab grades are counted in with the class and stuff. So whoever you're in a lab with, that's who you're going to be getting your grade with. My class did really well with this so far today. I'm recording things kind of a day in advance for y'all. So my class did really well with this. I was very proud of them during my third period. They got in here. Both of the people in the remote were talking through the lab with them, watching and everything like that. So for some reason you can't make the time of your class, I just need you to shoot a message across to your teacher and say, hey, I can't make this time. Can I come during this other class period? And we're really flexible on this, guys, because we understand that, you know, y'all need to share devices and maybe internet happens and stuff like that. But if you don't log in for days that we have these labs, then we're gonna start counting you absent because those are a requirement and it's part of the distance learning thing. So it's not that we're trying to pick on you. We want you to get the same education, and being able to discuss within a group is gonna make this a lot more of a transition for you when you come back, a little easier, but it's going to let you be able to talk to each other and get that social interaction that a lot of teenagers need during this time. So we did our lab on breaking down matter. Y'all filled out this sheet. You just don't know you filled it out because your questions and stuff went onto this one. So some of the things that we're going to be discussing whenever we do a wrap up of labs is we're going to discuss the lab. I'm going to kind of go into some other stuff, and I'm going to tie in a lot of the other topics that we might do over the year. Just so that you can kind of see where we're going and that it's not new information whenever we get there. So, excuse me. Some things that we noticed about the sugar cube when you hit it was that basically physical change happened. Every time between the sugar cube and with the aluminum foil, we only had physical changes today. We did not have any chemical changes. A physical change is physically changing the appearance of something, because we talked about physical properties is describing the object, and you can use your 5 senses to do that. With physical change, it's a change that happens physically, so it changes the appearance of the element or whatever the substance is, but you never get anything new with it. A chemical change, we're later going to discuss about chemical changes that you do get a new substance with it. So everything in our lab, with the sugar cube and the foil, those both went with physical changes. So you were supposed to list some physical properties, things that described it. Things like with the sugar cube, that it was white in color, that it was hard texture-wise. You could name anything about it being brittle because we can break it easily. You can talk about how it kind of looks a little grainy and stuff, and that the light reflects a little bit off of the little crystals, sugar crystals in it, and things like that. This one, the size is small and stuff. So whenever you hit it with the hammer or the rubber mallet, what you should have noticed was that it just became smaller and smaller. We never got a new substance with this because we only did a physical change. The word physical, meaning how it appears and things like that, the physical context of it. We asked questions like, is the smallest particle still sugar? Yes. Because I didn't change my substance. In order to get something new from that sugar, we talked about it in my third period, I would have to like heat up that sugar cube to caramelize it. That's still sugar, it's just caramelized now and stuff. I didn't get a new substance. We'll talk about indicators of that later. But the foil, all y'all did was you kept tearing it down until you got a small piece that was really hard to see, but it was still aluminum. We didn't change that. Now, one thing that I did discuss with my kids, because they were saying that a physical property with the aluminum foil was that it was brittle. Now, the aluminum foil is brittle, but real aluminum's not. I want you to think of aluminum siding, or you can talk about like, I don't know. I have some aluminum nails back there in the back that we use for one of our labs. That's from my grandpa's tool shed, where they used to use aluminum nails to go into any kind of carpentry and building and stuff. So those you have to hit and flatten with a hammer. That makes it malleable and stuff. This foil we don't have to, but it's been thinned out enough already for us to use it, that I should be able to think, okay, it was malleable anyway because it's already been thinned down for me. It never changed physical property of that aluminum foil. It was that had luster, it's silver. We can talk about how it was flat. It was kind of smooth and things like that. There's all kinds of different physical properties, anything to describe it. Never once did we have a chemical change with this. Okay, we just physically changed it, and we physically changed the shape and the size of it. That's all we did with both of these things. All right, so that's stuff that you should have got out of today's lab that we did, or yesterday's lab if you're for this video tomorrow. The next thing that I have on there for y'all, my kids went ahead and did it. We got the green piece of paper, and it's actually in remote classroom. It's called the timeline of an atom. So what I need you to do is I need you to get that piece of paper. You're gonna cut them down into strips like this with their writing and everything on it. And then you're going to look at the dates on them and put them in chronological order. And that's part of the directions that were on there. Now, some of you might be doing this on Thursday. Some of you might be doing it on Friday. I'm hoping that you already did it for Thursday this week. And then you need to upload a picture. You're gonna look at it and you're gonna say, well, there's two 400 BCs when I'm looking at this. Yeah, there are. But if you read closely with it, you're gonna see that the 400 BC, one of them says, well, he didn't agree with this person. And so you're gonna know, well, obviously the other one had to go first in order for this to be a true statement. So you're just gonna glue them down in your notebook in chronological order. So I'm gonna show you real quick. My notebook, I've been doing one for my remote learners, just like I've been doing with the in class. Every class has their own one. So we have this. My lab sheet for me is gonna go here, and it's just so in my notebook that I know next year when I'm teaching, this is what I taught. So I'm gonna fold my lab sheet and I'll glue it down here, okay? Then over here on the next page, at the top of it, I'm going to write in it timeline of an atom. It helps if I can spell, I'm so sorry. So you need to be doing this with me. Timeline of an atom, and if you need to pause the video, please do. So you can cut out your little strips and everything like that if you don't already have it. So then what I'm gonna do is I'm gonna look at these strips. And I'm just gonna kind of lay them out real quick in chronological order so that we can discuss this. And the bell might catch me here in a minute. If it does, I'll upload another video. All right, so pause, and I want you to do that real quick if you haven't already, and then come back to me. Those of us that have, what we're gonna do is we're gonna look at it. The first one we're gonna talk about is 400 BC, Greek philosopher Demetrius thought that he could cut the particles up, but eventually end up with a particle that could not be cut. He called this particle atomos, meaning not able to be divided. So whenever he first started this in 400 BC, looking at things, he thought that eventually I'll get to a small enough part that I can't go any further. So kind of a guy before his times. And if you think about technology back then, at 400 BC, it was before Christ. So obviously 400 BC is way before we had anything that could break down the atoms and even let us see the subatomic particles. Later that year, Aristotle, a Greek philosopher, disagreed with Demetrius. When he did not believe that such a particle be made up of a substance found in nature. So he didn't think that we could be able to see them out wherever and stuff. And you know, these guys, you just kind of, it was theories back then. They really couldn't prove their points too much, but they kind of thought about it. All right, and it's just kind of like with space. We're learning new things every day because technology is always changing with space. I mean, things that we see in the sky right now, literally a star is being born right now, and we won't see it for thousands of years. And the reason we can't see it is because by the time that light gets to us, dealing with that distance, guys, it's years and years for it to get through that whole amount of space. So things are always kind of changing in the timeline of science because we're always finding new things out. Now, some things are concrete. We know gravity works. We've already been able to prove this. Obviously, if it didn't work, we'd be floating off everywhere and stuff. So after that, in 1808, John Dalton stated that an atom of a certain elements are identical but different from atoms of all the others. So what he figured out in 1808 was if it's oxygen and has 8 protons, 8 neutrons, and 8 electrons. Every single element that we found that had 8, 8, and 8, they're all oxygen. It can't say, oh, well, it has 8 and now we're going to say it's neon. It's not. Once it's assigned that number of 8 protons, it's always going to be that way. And that's actually how we identify elements, is based on how many protons they have. So you should be getting that in your reading today. When you're doing your reading notes, you're going to start learning a little bit about that, all right, about these subatomic particles. All right, so that was my third thing that I just glued down. My next thing is in 1897, J.J. Thomas, not J.J. Watt, which if you were in my room, you'd see I love J.J. Watt, but J.J. Thomas provided evidence that atoms are made up of even smaller particles. He found particles with a negative charge, known later as electrons. He thought that the atom was a positive sphere and the electrons mixed throughout. So as technology and things are changing, and as we're getting to explore and we're actually having more scientists look at these things, we're able to do more research and we're able to get more information. And now we know that we have little negative electrons. And I think of them like kind of little mustaches and stuff. And what they do is they float around the middle of this atom. Okay, so they float around the middle part of this atom. All right, and that middle part, he said, was a positive sphere. Well, we know that the middle, the positive charge is going to outdo. All right, so we're going to actually look at that too next week. We're going to talk a little bit about that. In 1909, Ernest Rutherford, and we actually have an element named after Ernest here, conducted an experiment to study the parts of an atom. He suggested that the atoms have a nucleus, small dense center with a positive charge, surrounded by moving electrons called the positive charge particles, protons. So now we're starting to figure out, okay, so there are protons in there, and now we figured out, okay, they have a charge. They actually give off something and stuff. So old Ernest here in 1909 was starting to figure this stuff out. He had had all these other people before him. In 1913, a man named Niels Bohr made an observation that led to the theory of how electrons in the atom behave. So he started to realize that these little minuses that are all over the place started acting a certain way. All right, and he really helped us with the arrangement and being able to tell what our periodic table does and be able to identify a lot of these things with these elements. He agreed with the positive nucleus surrounded by electrons, but moved in a circular path around the nucleus. This model helped predict the chemical properties of elements. Niels Bohr actually came up with the periodic table. He's given credit for the periodic table. That's where we have all the elements classified based on different properties, chemical and physical properties, and based on their valence electrons. Now, valence electrons are different from electrons. All right? Well, you're going to learn this later, but I'll give you kind of a heads up. Valence electrons are electrons that share between elements to let them combine. So water, H2O, I know I need 2 hydrogen to go with my oxygen. So they kind of have like a little symbol with them that says, okay, hey, you can go and find another element, all right? So this is the timeline of my atom. The next thing you're going to do is you're going to do the reading notes. Now listen, here's the thing with your reading notes. Everything is due by midnight tonight, all right? So midnight Friday, everything needs to be submitted. If not, then you're not really doing our work and we're not going to give you attendance for it. That's kind of the policy. I work overtime here to make sure that you have the videos ahead of time so you don't fall behind and stuff. So we're asking you to do your end of the bargain. We're always available to answer any questions, but you need to make sure you're writing in complete sentences, especially if you're not printing out the reading notes and stuff. And a lot of my kids, I've been giving comments back, letting them know, hey, here's your grade, but here's what you're missing in your reading notes. So please go back and fix that. Just kind of touch base with us teachers. Come back and forth with us. Let us know if you have any questions, if you have any concerns and stuff. So this is Friday's lesson. Y'all have anything you need anything, just shoot us a message. And then next week, we kind of figured out a way that we're going to fix those for you to where next week, all you do is you click on Monday and everything that you need to do on Monday is on it. And then you'll click on Tuesday, everything for Tuesday will be on it. We're just kind of figuring out simpler things for y'all, and we're just really trying to help you out more than anything. So if you have any suggestions, y'all totally just let us know and stuff. I'm Miss Strizich. I hope you have a great weekend. I enjoyed getting to see my remote learners today. It was super exciting to finally get to put a name with a face and stuff. So we're hoping that y'all will be able to join us a lot more. I'll talk to y'all later. Bye.